All right, we're looking at topic 1-2. This is day 2 of this topic, and we are looking at this question that we start off with: are AC and BD congruent? Well, I guess first we need to know what that word congruent means, right? Congruent in this case, the way we're talking about it right now, is that two line segments are congruent. That means they have the same length. All right? Now remember, when we're talking about line segments, there's only one dimension that you can actually measure with that, and that's how long it is. Okay? So segments are congruent. If two line segments are congruent, that means they have the same length. All right? Quick note on the notation for congruence. Okay? When you have this symbol right here, it's an equal sign with a little squiggly on top of it. That means two things are congruent to each other. Okay? And you know how when you have a number, it's like 4 is equal to 3? Well, we know that's not true, so we put a slash through it. Okay? Congruent works the same way. If something is not congruent, you put a slash through it. That means not congruent. What that is. All right? So, if we are to answer this question, are AC and BD congruent? What we need to do is follow 3 steps. Step number 1, find the length of the first segment. What you're going to put in that blank right there is AC. Okay, remember when you're using when you have 2 letters like that, but there's no line or segment, anything on top of it, you're talking about the length, the distance between A and C. All right, so let's do that. AC is going to be found by subtracting. We've got A at -2. We've got C at 5 right there in the middle of it. So we go -2 minus 5. So we get -7, and we ask the question, why are we taking the absolute value of something? Okay? I asked this question in response. Does it make any sense to say that I am -3 feet away from a desk? Does it make any sense that your line segment would be -7 units long? Okay, the reason we're taking the absolute value is because we should end up with a positive answer. The only way to do that is by taking the absolute value. Okay, distance is always a positive number. So that's why we take the absolute value. Step number 2 is find the length of the second segment. In this case, it's BD. That's what goes in the blank right there, BD. And we're going to do exactly the same process. We're going to subtract 3 and 10. So we take 3 minus 10, take the absolute value, make sure we end up with a positive answer. Step number 3 is comparing those lengths. Okay? If we end up with the same number, the 2 segments are congruent. If we end up with different numbers, then they're not congruent. That's it. Okay? If we get the same length, it's congruent. Different length, not congruent. Don't make this too difficult. All right? So what we're doing is we're comparing those 2 lengths to each other. And so we ask the question, how does 7 compare to 7? We know that 7 is equal to 7. So since those lengths are the same, those segments must be congruent. So the answer, are AC and BD congruent? Yes. Yes, they are. The next question is asking a very similar question. It's asking, are AD and CE congruent? All right, so we can do the same process. To find AD, we subtract -2 minus 10. -12, we get 12. All right, take the absolute value, we get a distance of 12. For CE, we go 5 minus 14. That's -9. So we end up with a distance of 9. 12 is not equal to 9. And since those lengths are not equal, those segments could not possibly be congruent. Okay, the next thing we're talking about is a midpoint and segment bisector, okay? The midpoint of a segment, that is a point that divides the segment into 2 congruent segments. Okay, what that means is the midpoint, for example, on this little diagram right here, would be B. And the reason we know is because this distance from A to B and this distance from B to C are equal to each other. Now there's a quick thing about notation that comes up that's going to come up a lot throughout the whole rest of this class. And that's these little symbols right here. These little hash marks right here. Okay? If you have two line segments with the same number of hash marks on each one, that tells you that those two are congruent. Okay? So when we see that AB and BC both have two hash marks, that's how we know that B is the midpoint, because those two distances from here, the two distances from here to here and from here to here are the same. So the next thing is talking about a segment bisector. A segment bisector is a point or a line or a ray or another segment, and what it does is it intersects a segment at its midpoint. It intersects a segment at the midpoint. Okay, so let's talk about what that means. It meets at the midpoint, okay? So it brings up the term bisect right here, okay? In the left-hand side of your paper, it asks you to define bisect. Bisect, that word by itself, means cut in half. Okay? Bisect means cut in half. Now, we already know what intersect means. We've seen that in math classes before. Intersect just means that they cross each other. Now, what I'm getting at here is that intersect and bisect are not necessarily the same thing, okay? We can say out here close to the school that 287 intersects I-35. But I-35 goes all the way from South Texas way up to Minnesota, okay? Just because 287 meets it right there, crosses it right there, that doesn't mean that it's bisecting it. Bisecting it means it cuts it into two equal pieces, okay? So the midpoint of I-35 is somewhere way up north of here, okay? So if it doesn't go through the midpoint, it's not a bisector. So intersecting and bisecting are not necessarily the same thing, okay? When we look at this picture right here, the line L right here goes through the midpoint. And since it goes through that midpoint, that is a segment bisector. So the next thing we want to do is find the midpoint on a line. All right, this gives us some information that AB has endpoints at -4 and +9. Then ask us to find that midpoint. Okay, method number one is pretty simple. We're going to draw it on a number line. Okay, you can place points at -4 and +9, and then just count in one little chunk at a time. We count in and in and in, and we end up at 2 and 3. So we know, going one at a time, that it must be somewhere right in the middle of 2 and 3. We point right there, and that would be at 2.5, thereabouts. Okay. Method number 2 says to use the distance. By the way, keep that little bit of information in mind. That 2.5, keep that in mind as we move on. Okay? Next thing we could do is to use the distance. Step number 1 is to find the distance. So in this case, that would be just like we did before. We subtract -4 minus 9. The absolute value of that would be +13. Step number 2, cut that in half. All right, this d over 2 is 13 over 2, 6.5. Step number 3 is to use that half distance to find the midpoint. So from the left, we're going to add 6.5, which gives us 2.5. And then from the right, we subtract 6.5, and that gives us that same thing, okay? That right there, that 2.5, that's our midpoint, okay? In my opinion, both of those methods are a little bit long and convoluted. They both work. They will both work every time, but they're sometimes kind of difficult. This next one, method number 3, is the one that I go to, okay? Method number 3 is labeled as the midpoint formula, but it's not really that fancy, okay? It sounds a lot fancier than it actually is. The midpoint formula just says that we are finding the average of our two numbers. Okay, the formula itself is a plus b divided by 2. Okay, so in this case, our a and b are -4 and +9. So when we add, we're going to substitute those in and say that's -4 plus 9 divided by 2. Y'all, that's 5/2, which is 2.5. And isn't that so much easier than those other two methods? All right, so don't make it more complicated than it has to be. Just find the average of the two numbers. All right, the last question that I did not answer on the left-hand side of your page is this: can you find the midpoint of a line? And I would direct your attention up to the top, the very tippy top of your paper. Topic 1-2, measuring segments. The only thing that we have worked with in this entire section is segments. We have found the midpoint of a segment. And a segment, like we talked about, has two definite endpoints. A line does not have any endpoints. In fact, a line has arrows that point in opposite directions that go on and on and on forever. Okay? If there is no beginning of a line and no end, then how in the world are you supposed to find the middle? All right? It is a trick question. Can you find the midpoint of a line? No. You can only find the midpoint of a segment. All right? That's all we have for this lesson. You already have the homework paper. If you've not picked it up, then here it is. Here's all the problems that are on it. All right? That's all we have for this lesson. We'll see you on the next one.